Okay, so I thought I'd just talk through this Google Doc that I created for this practice test question. Now, as I said here, that sometimes having a picture really helps, and Venn diagrams make a great picture. Dr. Stevens isn't into them; he doesn't use them, um, but I'll often talk about them with students if they ask questions about them, about probability. So what you do with the Venn diagram is you make a couple overlapping circles. Well, if they overlap, in this case, they certainly do, because we've got some people that own dogs and people that owns cats, and we're thinking there must be some people that own both, right? And then they're telling us that 60% of the U.S. households own a cat and a dog, or a dog, or is important. Okay, so here's the Venn diagram, and as you can see, I did a circle for a dog, circle for a cat, and the overlap. And so here's where the 39% comes in. 39% of the people own dogs, so that's that whole green area, green circle. And then 34% of the people own cats, and so that's a notice there's some overlap going on here between the own a dog and own a cat. So that must be the probability that they own both. And they didn't tell us that. So how do we figure that out? Well, they did tell us that 60% of people own a cat or a dog. Did they word it so that say or both? Own a cat or a dog. So they didn't word it that way. So, but what you gotta infer, and this now you need to go back to that addition rule that Dr. Stevens set us to. So this is the probability of event A or a probability, or B is probability of A separately plus the probability of B separately, or the probability of owning a dog plus the probability of owning a cat minus the probability of owning both. So how does that play out with this? With this? Well, I set up the probabilities, and then I just did a little bit of algebra here. I combined the 39%, the 34%. I made them a decimal, right, to work on probabilities. And then I subtracted it, and that's a little panic-inducing that 60% is smaller than 73%, but you get a negative, and this is being subtracted, so then negatives cancel out. So 13% of the people own both a cat and a dog, and that's that red intersection spot. So that answers part, see, I'm kind of working backwards here as far as answering these questions. I think that's our last question. Is that what's the probability? No, that's B. That's B, probably both a cat and a dog. Okay, and then why do we answer part A where it says neither, oh, there's a typo. No, either, neither, that's right. Anyway, that's that gray area, right? And that's outside of that. Well, that white area corresponds to all that area, right? And we know that's 60%. So 1 minus 60%, or 100 minus 60 is 40 at 0.4. Okay, so that's easy. In fact, the question in the discussion forum, the person answered this. Sorry that this is generic. I want to use this in future semesters. Then comes the last one. What's the probability that a randomly selected household owns a cat if the person has a dog? So that's a conditional probability, probability of a cat given a dog. So if we go back to that Venn diagram, this is, so the green area, right? The green area is this hole here. Let me get a pointer. It might show up a little better. I'm sure, I mean, I know my cursor does too, but the pointer will work better. So this is the probability that somebody owns a dog. Now, in that probability of these people that own a cat also is that red intersection. So remember, the conditional probability is the probability that they own both, given that they own the other, or the so what you do basically is you'll do that, you will use that 0.13 divided by the 0.39, or 13 divided by 39, and that works out to be 0.33, or a third. Now maybe this Venn diagram thing get thrown in at this late date is confusing this heck to you and you don't like it. Okay, so what we can do is since we did use tables with Dr. Stevens, and there's two criteria: owning a cat, owning a dog, and then their complements, right? Of not a cat, not a dog. So I set up this table here: own a cat, not own a cat, own a dog, does not own a dog, and I said if there's 100 Americans, say, pick an easy number. If 39% of them own a dog, that's 39 out of the 100. So own a dog, I put the 39 here. Own a cat, well, that's 34, I put that there. And I know that 60% own a cat or a dog. So I couldn't really apply that here yet. But what I did know, if there's 100 Americans and 39 of them own a dog, 61 don't, 100 minus 39. And the same thing here, 34, 100 minus 34 is 66. Okay, so then we had to, now there's no getting away from it because what they told us, we have to use that addition rule. And so I just set it up with these numbers that we came up with, same numbers, just in a different form, right? So we know 39 out of 100 own a dog, 34 out of 100 own a cat, and both out of 100 is the other probability. That equals 60 over 100. So, I mean, since these are both over 100, we can kind of forget about it. Algebraically, we could multiply both sides of this equation by 100 and clear it, right? That leaves 63 equals 73 minus both. See how the same numbers are appearing? So that tells me 13 own both. Okay, so that's on my table. Own a dog and own a cat, there's 13 of them. So now that allows me to fill in the rest of this table. If 13 own both and 34 own a cat, that's got to be 21, 34 minus 13, right? And if 39 own both and 39 own a dog and 13 own both, that's going to be 26. And then to fill in the rest of this, well, if I know together that's 34, 13 minus 34 minus 13 is 21, and 26 minus 66 minus the 26, it will be 40. So then I can see how many don't own a cat nor a dog. Well, does not own a dog, does not own a cat. That's both of them. So 40 out of 100 agrees with what we did earlier. And I think we've got I think we get everything we need. So there's nothing wrong with applying numbers to them. Okay, so hopefully this helps you answer that question on the practice test and the one about cars on the exam, if I'm still using that question when you watch this.